FY25 was an exciting year for the team at the Deer Creek Intake Project. We're now almost 3 years into construction and are finally approaching project substantial completion dates in early 2026. As a quick recap, the project is located at the Deer Creek Dam and Reservoir in Wasatch County, Utah. The dam was commissioned by the Bureau of Reclamation in 1941 and provides irrigation and drinking water to over 1.5 million Utah residents. It was a crucial piece of water infrastructure for a growing population on the Wasatch Front and continues to be. The project addresses the dam's aging infrastructure by refurbishing and replacing key components and installing a new bypass intake for operational redundancy, all without draining the reservoir or interrupting water deliveries. At the center of the project is an enduring partnership between the Provo River Water Users Association, the owner, Advanced Engineering and Environmental Services, the engineer, and Granite Construction, the CMGC. This project is truly the first of its kind in Utah, utilizing various subcontractors, and in 2025, we'd like to take a moment to thank our outstanding marine subcontractor, J.F. Brennan. Throughout the entire project, Brennan has been there, not only to perform highly skilled underwater construction work, but has also played a key role in planning for crucial project milestones and helping the team adapt to unforeseen circumstances. With all the risk and uncertainty involved, this project would not have been possible without Brennan's commitment to innovation, safety, and quality work. Since the project broke ground in May of 2023, much has been accomplished. The team was able to excavate on both sides of the dam to install the entry and exit portals for the micro-tunnel boring machine. The bypass pipe was then installed in 2024, with the MTBM completing its journey 75 feet underwater before being successfully recovered to the surface. Near the end of 2024, the project focus turned to excavating and demolishing a portion of the original penstock tunnel to make room for the new bypass vault. The vault houses all of the process piping and equipment that connects new bypass to the original turbines and plunger valves. The new process piping includes a 72-inch diameter steel pipe, which connects the new microtunnel pipe to the existing 72-inch penstocks. Each tie-in point is equipped with 72-inch double offset high-performance butterfly valves for isolation. A2S designed smaller valves and piping to control the filling and the draining of the bypass. New instrumentation is included to monitor data like flow rate, pressure, and to control the opening and closing of each valve. Operators can remotely access the data using their existing SCADA controls. After the well-deserved holiday break, the team was back to work installing rebar and formwork for the vault walls in early 2025. Just like the floor slab, the walls were designed to join seamlessly with the existing penstock tunnel. With each of the 4 wall lifts, features were added to prepare the vault interior. Structural steel beams bolted to embedded anchors. Floor gratings, railings, and ladders were installed to provide safe and easy access to all parts of the vault. Outside the vault, Granite began to backfill the walls using processed native material they had excavated during the first phases of the project. This same native material also provided a subgrade for the access road. An MSE wall, that is a mechanically stabilized earth wall, was built on the far side of the vault to restrict access to enclose the parking area. With a few final touches, the vault was ready for startup. On the other side of the dam, Brennan's divers were remobilizing on the barges to install the bypass intake and trash rack. The new intake was designed to fit onto the upstream end of the 72-inch microtunnel pipe that was installed by Fowler in 2024. It was delivered in 3 sections and coated on site. The first section includes a special fitting that was cut from the tail end of the same microtunnel boring machine that completed the drive. The exposed intake will be secured in place by pipe supports, turnbuckles, and a custom steel thrust restraint frame. At the end of the new intake is a hinged 72-inch blind flange weighing nearly 4 tons. This blind flange can remain open except during future manned inspections of the bypass. Finally, a welded steel trash rack cage will enclose the opening to protect the bypass from debris. The trash racks are coated with a specialized foul release coating to prevent attachment of aquatic invasive species. At the top of the trash rack is a circular hatch providing access to future divers and ROV inspectors. By mid-September, the new bypass was fully assembled and ready to be turned on. For the first time, water was flowing through Deer Creek Dam without the use of the original intake. It was finally time to get to work on the core purpose of the Deer Creek Intake Project, the guard gates. Before we could access the guard gates for rehabilitation, we needed to dewater the entire intake system. This was no easy task and has never been done in the 84 years since the system was first filled in 1941. To accomplish this, the team created watertight seals on both openings of the original intake. Using measurements taken by Brennan's divers in 2024, 2 custom bulkheads were designed, fabricated, and tested for this critical task. The larger of the 2 bulkheads would be 192 inches in diameter, too big to be installed into the intake as constructed, but the team had prepared for this, removing one of the intake's original concrete beams in 2024. The bulkheads arrived on site in September and were loaded onto the barges to be brought out to the work area. The 42-inch bulkhead was installed first and required some of the deepest dives of the entire project, almost 130 feet deep. The 192-inch bulkhead was then carefully installed using a custom lifting frame with a winch that could be operated from the surface to rotate the bulkhead precisely into place. An HDPE vent line was installed through the valve on top of the bulkhead to relieve vacuum and pressure during dewatering. With all safety measures in place, the team began to carefully drain the intake. The draining process was monitored closely and took approximately 30 hours to complete. When the water slowed to a trickle, Granite opened the steel manway on one of the penstocks and confirmed minimal flow. It was time to enter the tunnel and see what the intake looked like after almost a century of continuous operation. All members entering the tunnel were required to use self-contained breathing apparatus, and accompanied by a certified tunnel rescue operator from DXP Enterprises. The team performed a thorough condition assessment on the intake and concrete tunnel, and despite the infiltration observed in some of the tunnel's cold joints, the system was found to be in overall great condition for its age. Just above the tunnel entrance, specialty hydraulic subcontractor ISS was quickly transforming the guard gate chamber into a workshop. A temporary gantry crane was installed and a mobile machine shop was set up on site. For security reasons, the exact location and configuration of the work area cannot be shown publicly. Instead, what we show you here is a conceptual layout of the gates and how they function within the outlet works system. A guard gate is a heavy-duty safety valve used in many hydroelectric dams to quickly stop the flow of water if something goes wrong downstream. Under normal conditions, the gates stay fully open so the water can pass through the system and power the turbines. But if there is a problem, such as an equipment failure, maintenance needs, or a damaged pipe, the gates can be lowered to rapidly shut off the water. Rehabilitation of the Deer Creek guard gates included full disassembly of each gate, cleaning and inspection of materials, recoating, and custom fabrication of replacement parts. Each gate was then carefully reassembled and fully tested before placing back into service. With 3 long years of construction behind us, the Deer Creek Intake Project is approaching its final milestone. This historic achievement illustrates the value of out-of-the-box thinking and strong collaborative partnerships in the water industry. Like the dam builders of generations past, the Deer Creek Intake Project team faced many difficulties and addressed each of them with the same ingenuity, humility, and resourcefulness that first brought them together. As we continue to address the issue of aging infrastructure over the coming decades, there will be more projects like this one. AE2S would like to thank the Provo River Water Users Association, Granite Construction, and all the partners who have touched this project to make it the success that it is.